Good morning. I am Munde SU from Vishwesharya Polytechnic College, Almala. Today in this lecture, let us see some important example related to formation of differential equation. First example is that before going to learn this example, first we study some step in process of formation of differential equations. First step is that observe the given relation carefully and find out number of arbitrary constant present in this relation. Let it be n. So when you start to form a differential equation, first step is that observe that find out how many arbitrary constants are present in the given relation. Consider that let n arbitrary constant present in the given relation. Note or step second, differentiate the given relation successively n times, and this gives n more equations. Now differentiate the given relation successively n times, and this gives n more relation. Means how many arbitrary constants are present in the given equation? We have need to find out derivative at that point, at that times. Means if one arbitrary constant is present, then take only one derivative of the given relation, and if two arbitrary constants are present, then take two derivatives of the given relation. In our syllabus, maximum two arbitrary constants are used, so up to second order derivative we have to find out the derivative of the given relation. Third step is that we have total n plus 1 equation including original relation. Eliminate an arbitrary constant using these n plus 1 equations, and for this purpose you may use determinant or method of substitution. And here last step is that last step it says that by using this all n plus 1 equations, we have need to remove an arbitrary constant from the given relation, and by using the process of determinant or method of substitution, you can solve and remove this an arbitrary constant, and when you remove this arbitrary constant, then you get a differential equation of the given relation. So by using these three steps, we can form a differential equation from the given relation. We study some examples. First example is that example number 1. Form the differential equation whose solution is y equal to ax square. Means in this type of examples, such type of example can be asked, and given that form the differential equation, order that form the differential equation, and given that one relation, that is y equal to ax square, and by from this relation we have find or we have to form the differential equation. So first we write this relation, that is equation number 1, and observe that how many arbitrary constants are present. Yes, only one arbitrary constant, that is a present. So take only one derivative of the given relation. after taking derivative we get dy by dx equals to 2ax. dy by dx is equals to 2ax. Okay, this is, and now from this equation 2 find the value of a. From equation 2 find the value of a where along a 2 and x is present. So going to LHS, then what happens? A equals to 1 by 2x, because 2x are in multiplication. When it goes to another side they become division, that is 1 divided by 2x into dy by dx as it is. So in this manner we get the value of a, that is this term. A is equals to 1 divided by 2x into dy by dx. So in this manner we get the value of a. Now put this value of a, which is come from equation 2. Therefore put this value of a in equation number 1. So when we are putting this value of a in equation number 1, then we get the equation, that is y equal to 1 by 2x into dy by dx into x square. And where what happens? Where what happens? Where what happens? Here x cancel out. This x and x cancel out. So what is remaining here? When these two x are cancelled out, this x and this cancel out, then what happens? Y is equals to x by 2, where x comes here, x by 2 into dy by dx. So what happens? X by 2 into dy by dx, and this can be written as x by y into dy by dx can be written as x into dy by dx is equals to 2y, because when this 2 goes to here, then y into 2y, where 2y present, and here what remaining? Dy by dx into x. Therefore x into dy by dx is equals to 2y, or x into dy by dx minus 2y equals to 0. So this is the required differential equation which is obtained from the given relation. So in this manner, by removing an arbitrary constant, we can form a differential equation by the given relation. Now we study next example. Form a differential equation if y equal to a into sin x plus b into cos x. Now this is differential. This is an example. Example number 2. Example number 2, form a differential equation. We all need to form a differential equation, and given relation is that y equal to a into sin x plus b into cos x. Now write this the given relation. Y is equal to a into sin x plus b into cos x, and observe that how many arbitrary constants are present? Yes, two arbitrary constants are present, which are a and b, and therefore how many times derivative we have to taken? 2 times derivative we have to taken. Now taking their derivative successively 2 times. So first of all, differentiate the given relation. Therefore derivative of y becomes this is derivative of y becomes dy by dx, a to a as it is. Okay. And derivative of sin x cos x, b as it is, and derivative of cos x minus sin x, and this minus goes to plus into minus minus, so sign change, and finally we get the value dy by dx is equals to a into cos x minus b into sin x. So this is first derivative. Now again taking differentiation, then derivative of dy by dx becomes d square divided by dx square, a as it is, cos derivative of cos x minus sin x, okay, minus minus as it is, will be as it is, and sin x derivative of sin x cos x. So in this manner we will get the derivative, both derivative, that is dy by dx and d square by divided by dx square. And after finding out that derivative, we have need to remove the given arbitrary constant. So when we observe the second order derivative, that is dy by dx, this derivative dy by dx d square by divided by dx square is equal to minus a into sin x minus b into cos x. Taking out minus common, then what happens? Taking out minus common, then what happens? minus is common here, minus is common, and remaining term is a into sin x plus b into cos x. And from equation 1, what is this? This is y. So here minus is forgot, so here is equals to what happens, y minus y. So here becomes minus y. So now we get the equation d square y divided by dx square is equals to minus y, and this implies that d square y divided by dx square plus y equal to 0. So d square y divided by dx square plus y is equals to 0, and this is the required differential equation. This is the required differential equation which is obtained from the given relation y is equal to a sin x plus b cos x. It is very easy. First, identify how many arbitrary constant here, taking that times of derivative, and remove the arbitrary constant. We get finally required differential equation. Now we will study another example. Example number 3, which is so easy example. First we read example. Form differential equation and given relation is y square equal to 4ax. Identify how many arbitrary constant is present here. Yes, only one arbitrary constant is present here, and that is a, is the arbitrary constant. So we have to take only one derivative of the given relation. So the given relation is y square equal to 4ax, and their derivative is derivative of y square, derivative of y square 2y into dy by dx. Because y square is a composite function, therefore derivative of y square is 2y, and y is separate function, therefore taking separate derivative, that is dy by dx. So derivative of y square 2y into dy by dx is equals to 4a constant, 4a constant, so 4a constant as it is, and derivative of x 1, and 4a into 1, that is 4a. So in this manner we get the derivative of given relation, and the derivative of given relation is 2y into dy by dx is equals to 4a, and from that we get y into dy by dx is equals to 2a, because 2 1s are 2, 2 2s are 4, therefore we get y into dy by dx is equals to 2a. Now after that the first equation is y square is equal to 4x, y square is equal to 4ax. It can also be written as 2 into 2ax, means 4x can be written as 2 into 2ax, therefore y square equal to 2 into 2ax. Now from equation 2, the value of 2a is, from equation 2 value of 2a is y into dy by dx. Now put this value of 2a in the equation 1, that is y square equal to 2 into 2a into x. At the place of 2a, put the value of 2a from equation number 2, therefore we get 2 into y dy by dx into x, and simply can be written as y square equal to 2xy into dy by dx, or y is equal to 2x into dy by dx, or 2x into dy by dx minus y equals to 0. And these are the required differential equation of the given relation. So these are the required differential equation of the given relation. So this is one important example, and now we studied another one important example, that is this. This is also simple example. Form the differential equation if y equal to 4 into x minus a bracket square, where a is an arbitrary constant. Here our work become very simple, because here mentioned that how many arbitrary constant are present here. Only one arbitrary constant is present here, so taking derivative of the given relation for only one times, therefore we get that is our equation, given relation y is equal to 4 into x minus a bracket square. This is equation number 1. Now taking their derivative, therefore we get the derivative of y dy by dx 4 as it is, and derivative of x minus a bracket square. So by the rule 2 in multiplication, and the given function as it is, x minus a as it is, and power is decreases by 1, that is 2 minus 1 1, and we don't write 1 in the power, so only x minus a is term is present here. So in this manner we get derivative, that is dy by dx is equals to 4 into 2 into x minus a, that is dy by dx is equal to 8 into x minus a, and from this equation 2 we can find the value of x minus a, and that is x minus a equals to 1 by 8 into dy by dx. Now put this value of x minus a in equation number 1, and when we are putting this value of equation of x minus a in equation number 1, therefore we get y is equal to 4 into at the place of x minus a, put this value 1 by 8 into dy by dx bracket square. Now y is equals to 4 into 1 by 64 into dy by dx bracket square, and it can also be simplified that y is equals to 1 by 16, y is equals to 1 by 16 into dy by dx bracket square, and that is the required differential equation. So in this manner we can find out the differential equation. Now we take another one example. Okay, this type of example. Here also ask that example, that is form the differential equation if y equal to ax square plus b, and we observe that here two arbitrary constants are present, and that two arbitrary constants are a and b. So we have to take two times derivatives, therefore we get dy by dx is equals to, now first we taking derivative of y equal to ax square plus b, so derivative of y dy by dx, and derivative of ax square 2ax, that is 2ax, and plus derivative of b 0 because b is constant. Now taking another derivative, that is again differentiate, therefore we get d square y divided by dx square is equal to 2a, d square y divided by dx square is equals to 2a. So in this manner we get these two derivative, that is dy by dx and d square y divided by dx square. Now from equation 3 we get the value of 2a. Now put this value in equation number 2, and when we putting this value in equation number 2, then we get, that is dy by dx is equals to x into d square y divided by dx square, where x as it is, and the value of 2a is d square y divided by dx square is putting here. So finally we can write x into d square y divided by dx square minus dy by dx is equals to 0. Finally what we can write here, x into d square y divided by dx square minus dy by dx is equals to 0. Okay, so this is the required differential equation which can be obtained from the given relation. So in this manner we can solve and we can form various differential equation by using the given relation, and process is that taking derivative, how many times, how much arbitrary constant are present in it, that times taking derivative, after that removing an arbitrary constant from the given equations, and then we get the required differential equation, and by using this process we can solve or we can form any differential equation from the given relation. Thank you.